Can't get enough.
Today we're going to talk a little bit about Hyper Converged. Were you guys in the session this morning? Yeah. Okay. So this one's not about a specific product. We're going to talk about trends, what Hyper Convergence is, what those definitions are. You guys familiar with Hyper Converged infrastructure? 32. This morning. You guys got a little bit of schooling. Today's going to be a little different. We're going to talk about what we're seeing in the industry, why this has come along, what these words hyper converged infrastructure is. What do you guys think converged infrastructure is today? If we're going to hyper something, we've got to start with that converged word. Yeah, so there's things that you understand today like flex pods, blocks, all kinds of stuff. Converged architectures, taking all of these different systems, putting together into a pod, into a reference architecture, into something that's all designed to work together. But it doesn't mean that you've got a single neck to read when there's a support issue. It doesn't mean that it's all going to necessarily scale or play nice together. So part of this hyper-converged world is taking that one step further. Not only just putting these pieces together, but to actually create a data center in a box, something that builds and scales easily. So we're going to talk through some of those things. Feel free to stop, ask questions. I'm going to try to make this entertaining. I've put together a new deck. We're going to talk about Legos and peanut butter and jelly. So first off, we see stuff in the news. So especially over the last 8 weeks, 3 months or so, Nutanix, Simplivity, HyperFlex, VxRail, all these kind of product announcements are coming out. And you'll see CRN and the Register and TechNet talking about all these different pieces of what's happening, who's doing what, how is this going to change the world, VMware in, VMware out, does it integrate with cloud? We read all kinds of stuff, but I always want to kind of go back to the basics and talk about definitions, because to explain anything or talk about anything, we have to understand where it came from. So this is a Google definition of hyperconvergence. Infrastructure is a software-centric architecture. So we hear software-defined networking, software-defined data center. This is where we're going, is moving all that innovation up. So a software-centric architecture that tightly integrates compute, storage, networking, and virtualization resources and other technologies from scratch commodity hardware in a box supported by a single vendor. Single vendor. No pointing fingers, no calling back and forth, all kinds of stuff. You guys ever open support cases? Not me. Not me. Not me. So we want to try to avoid some of that kind of stuff. But we'll come back to this definition a couple times as we talk about what these different products offer and what happens in the industry. So part of it is entering into this, we have to think a little differently about how we approach things. We've always done this in traditional block storage, one mentality, volumes, how do I carve things up, performance domains, failure domains. We also talked about protecting all of these things. How do we configure each one of these to work with the other? But if we think in that same mentality, we can't fix tomorrow's problems. We have to come up with something new, something different. Who played with Legos when they were little? I like this room already. I love Legos, right? So we're little, we start with Duplo, it's kind of easy. Big bricks, can't swallow them. I tried, it happened. You get a little further into the world, Castle series and all kinds of stuff. More bricks, more parts, better instructions, and we migrate, get a little older, techniques, right? Moving pieces, all of a sudden you understand how rack and pinion steering works. You actually get to put this stuff together. And then we grow up and we still play with big kid Legos. E-blocks, flex pods, data center. Serious, this is how it comes, right? A lot of packages, a lot of stuff. Instructions look kind of similar, right? So we put all these things together. It's called a reference architecture. We've got 70-page instruction manual, how we assemble technology today, how we all make it work together. We can try building our own too. It doesn't mean that it comes in a nice, pretty package. This is what we've done for years. This is what we've prided ourselves on. There's things on the internet just dedicated to how pretty cabling is. Did the zip ties match the color of the cable? Was it all bundled correctly? This was a huge part of our world for a long time. But we get in this mindset of, does that matter anymore? We've gotten into this age where we've kind of seen technology grow and evolve as it got past mainframes and green screens to this x86 world where we have individual apps sitting on servers and all kinds of stuff. Then we get into virtualization. VMware came out in 2003 and said, hey, we can get density on servers. Let's actually make some really cool promises here. And then when we can do that, what if we start renting infrastructure? So infrastructure as a service comes along. We start buying and thinking about the pieces we need. And then the conversation today is Docker, container. How do I move all this? Hybrid clouds, fabrics. You guys hear about Docker, containers, think about apps, those kind of things? It's always kind of tied to Web 2.0, Web 3.0 applications. We think about how do we containerize and package all these things. But how many applications do you install today that can run inside a Docker instance or in a container? None, right? We still got big fat apps, right? SQL servers. all kinds of stuff that was written for today's platform. So we still have to play in that world. We're going to get there. We're going to see the shift. But the trouble is that we're not there yet. There's still a lot of gaps to be filled in this infrastructure. So we talk about the cloud era. What are we seeing? Why are we seeing this? We want rapid time to market. We want one-click simplicity. I want to swipe a credit card. I want it done. Nobody wants to wait. 30-minute oil changes, big deal today, right? What else happens quickly? We see all kinds of advertisement. Everything's about saying this time. It's the one thing we can't create more of. So as we go through different technology, why won't we want time back? What if I want to buy exactly what I need? Can we go to Sam's Club and buy eggs? I only need like 5, 6 for this recipe. Does that make sense? No, I want to go buy what I need. When we talk about workloads, talk about what cloud is in this era of cloud coming along. Again, we don't see a lot of applications designed to fit in that cloud metric. SQL servers that stay on all day, that are only used from 8 to 5. Does it make sense to pay for that CPU all the time? Is that cheaper to run on-prem or to use CPU cycles in King Visa's little heaven up there, right, Hotel California? But we have to understand the workloads we do. What's the distance? Which ones actually work? Which ones don't? We start looking and evaluating this. Do you buy or lease a car? What makes more sense? Depends on the metrics. Depends on the use. Depends on how many miles you're going to drive. You start factoring all these things in. We have to look at applications the same way. But part of the problem is that we used to play with these kind of things. We built toys. We pretended it flew and all kinds of stuff. We rolled a little guy up. But our world shifted a little bit today. Why? Because we have these things. And you swipe that here. And this comes 2 days later. I want the one that flies, Mommy. I want the one that takes pictures. I don't want that anymore. I don't want to have to wait for it to be built. I want to play with it right now. Our business owners have gotten that same mentality. We expect that instant consumerization of things. Why wait? If I can go swipe and get in the cloud, why am I going to wait my IT department to deliver something 2 weeks later? So we talk about data center timeline. So we started here. This diagram hasn't changed much. Storage controllers, some sort of fabric, a server, an app on top of it. 2003, what came in? Virtualization. Density. Did that make things easier? Not really. It helped. We thought we got a better bang for our buck, but all of a sudden now I've got virtual switches and virtual I/O control and all these other different things that I have to pay attention to. New tools, new monitoring, all kinds of stuff. I've got consoles upon wiring diagrams that I'm trying to keep up with. When there's a SQL Server issue or a performance problem, I'm logging into my virtual console, into my storage, into my network, into all these different places trying to assemble information, right? And then we get these single panes of glass. Can we smash it all together? Can we make it easy? But we have tools out of tools out of tools. You guys use any of these tools? Familiar? My backup's running, something's happening, my forecasting capacity. We put all these things together, all bundled as part of different things. The projector's not perfect in focus either. That's not lunch. That's really good. You guys are starting to worry a little bit. But we're going to talk about Hyper Converged. We'll go over in about 30 seconds. We'll be done. The 3 circles. We always talk about good, fast, cheap, those kind of things. But what if we change it? What if we say that this works, removes constraints, and eliminates that work? We're going to talk about how that affects your infrastructure. We'll talk just a little bit about what's happening, how we're smashing all this into one little box, and then how does that affect your organization? Why bring this in? Why take a look at it? Why change anything you've done for the past 15 years, past 5 years, relationships you have with existing vendors? So let's talk a little bit about that definition of hyperconvergence. We're talking about where things are going. The bag phone came out at the same time RAID technology did. Today we still use RAID infrastructure. Look where phones have come. Right? We used to have a fanny pack. Camera, pager, cell phone, feature phone, all these kind of fun things. And if we wanted to actually get a video off that camcorder that we wanted to send to somebody in our family, there was some cable we had to hook to our computer. We had to download that, put it in some format that we could email or attach, or could we even do that and download the AOL to get it to go? There are all these steps, and let alone calling the person on the other end to actually walk them through playing that video. Today it just happens. We have this expectation that things just function the way we want to. So when we go to buy these things, do you have guys come on site and try to sell you cell phones? Is there an engineer that helps you size that cell phone? Sorry, do you need the 64 gig or the 32 gig?
Always the bigger one.
Go big or go home. I know how it works. Who comes to install it for you? Does Verizon send somebody on site? Your days of PS upgrade of your phone? You go to class? Some of us need to. I've had trouble too. I admit it. But we don't get a training certificate to use our cell phone. Who does your upgrades? Who migrates your apps over? We don't think about these things anymore. We expect them to function. What if we brought the same mentality to the data center? I realize I'm talking myself out of a job too, but that being the case, this is the way we see technology going. We see things changing. So we're going to talk about this in a couple of mindsets. We want it to be simple. We want to be able to scale out easily and predictably. We want agility. I mean, we always want to be flexible. How do we handle things? How do we shift as new organizations, new requirements to our organization? And security comes into play a little bit every now and then. By the way, I haven't confirmed this. Somebody told me over lunch that LinkedIn got hacked today. You heard that?
That's what we hear.
So, kind of crazy.
Who?
LinkedIn. Talking about millions of emails and passwords being compromised. Again, that is, I haven't seen that firsthand. But we talk about the things we want, the things that we see today. So let's start with what we have today. We have the security of our four walls. Who trusts about? We do with our pictures, right? Maybe our family stuff, some of those kind of things. What about your financials? Social security numbers? What are the guys on your police force? Those kind of things. It's a little more sensitive data. We know we can trust that. It's secure inside our four walls. It's somewhat predictable. We know how many IOPS we got on the drive and when we can push and all those kind of things. And we just have measurability out of that. And it's versatile. So we get applications from all the places. The marketing people walk in, HR people, there's some new payroll software happening. But we know that we can run it. We know it's formatted for x86. The problem is it takes us a long time to actually procure the new hardware, to get it installed the way we want to. We wish it was simple. We wish that we could grow that application quickly. We wish that it was delivered yesterday, not today. Business owners don't want to wait on this stuff. And this is what we call enterprise cloud. This is what we call enterprise cloud. Fix that slide. Again, we'll cover some of this stuff kind of quickly. This is the way we design data centers forever. Top rack switch, some sort of SAN platform. We had a fabric to connect it all together. SAN, iSCSI. We pick a server vendor. It's kind of a hard choice, isn't it? A lot of things out there. Profile management, all kinds of different pieces. How many people update all the BIOS when the server's regular? Happens, right? Reboots, all kinds of fun stuff. There's all kinds of pieces of management. We have choices of hypervisor today, all to run those things on top called apps. I mean, you guys go to business owners, application owners, second level managers, and start talking about runs and replication schedules and backup and all kinds of stuff. What do? Glaze over, right? Or they think you're cussing out, one of the two. But you get through this conversation, and it's like they don't care about where that app lives, they just want it to function. Well, what if we can make all that invisible? What if it was the same way we shifted from manual transmissions to automatic transmissions? We trusted to actually shift gear property for us, right? We don't look at the RPMs and we don't track all this stuff. We don't look at this hill and think, is it going to slow us down? No, we just expect when we push the gas, things happen. What if we trusted our data center infrastructure to do the same thing? So this is what we're used to, right? SAN, some sort of host. We got some mix of flash and SSD. Sized correctly, some caching algorithm. We're dealing with QoS and all kinds of stuff in here, trying to make it all. Yes, repeat my slides. Trying to make it all function properly. But what if we could kind of give you the best of all these worlds? What if we could kind of give you SAN functionality, the snapshot, view, compression, all these features you expect in enterprise storage, and a scalar module thing, and actually move that storage closer to the CPUs? It's what Fusion IO, it's what Pernix Day is, what all these companies have tried to do for a long time, is speed this process. How do we get data on the PCI bus close to where we're trying to use it, instead of having to go multiple hops across the network, get my data, multiple hops back to retrieve it? So this is the idea behind Hyper Converged, is taking all this and smashing everything into a simple box that actually functions the way it's supposed to. But we're still just talking about hardware at this point. Let's talk about why this stuff came about. So Yahoo was a predominant search engine when Google started. And two guys in a garage were like, how do we compete? We think what we have is better. We've got some venture capital, we've got some money flowing in, but how are we going to actually do this? We can't go out and buy the hardware we need, these massive arrays and all these switches and servers, and what if we actually could buy what we needed and scale it as we grow, as we got more users, we saw searches increase. And so this is where the Google file system came, and so this is where a lot of the founders of this hyper-converged era came out of. They came out of these large companies and said, we can decide to bring this to enterprises, to SMBs, to government, to accountants, to whoever needs some sort of simplified process like this. But they had a couple design principles. We're done with custom hardware. No more specialized forklift upgrades and heads and all these things. We want generic hardware. We want it all in the software so we can innovate quickly. We want always on type technologies. Today, when you have an internet problem, how do you know? What do you usually do? Try to go to Google, don't you? Try to ping Google, try to do something. So we've learned to trust Google's infrastructure so well that if we can't reach them, we assume it's our internet's problem. Wireless is down, something's happened. There's some service provider next door. I'm gonna be careful. I can't name your name. But we always wonder, like, is it us? It can't be Google. Google's not down. Why would Google be down? It's got to be my internet. So as we think about that type of infrastructure, would you sleep better at night having that inside your data center? Not worried about the next drive that fails or the 4-hour parts replacement or all those kind of things. What if it kind of self-healed itself? What if losing a drive didn't impact performance or anything within that infrastructure? We talk about quickly innovating. So software upgrades. You do them on your phone all the time. Is that difficult? Press a button and it works. So what if you got performance upgrades, new features, and all kinds of stuff to the equipment you already own simply by pressing a button? It's what the world we're seeing shifting towards. We're bringing this consumerization inside the data center. Always own systems. We want things to stay up. That's the SLAs we guarantee, these kind of things. When's the last time Amazon scheduled a maintenance window? No, they've had some outages. We laugh at it, right? Netflix had a little bit of issue with crossovers, but we see things not going down anymore. There's not these large things. We don't see people taking time from their weekends and from families and vacations to go fix things anymore. So you built this, and your boss walks in and he says, I want this. The only problem is this is how you have to buy it. You have to use that to build this. You got to figure out, well, can I rip part of the foundation out? Do I add that spire on the top? Can I even procure those parts anymore? This is kind of an old set. So we start trying to figure out how to build this in pieces and parts. All out of little things to get to this thing of whatever they ask for, and you know this is not the end of it. So what does this linear predictable scale out mean? What if I could add server by server as I understood my workload? What if it was by number of users? What if it was by VM count? What if it was by events per second in a Splunk setting? One server at a time, linearly, understanding we don't have to go to the well, we don't have to take guesswork, we don't have to go through a parking lot of broken glass to figure out what the next 3 years of business looks like and hope I guessed right. Who enjoys doing that? It's kind of tough, right? Yes, sir, I need this X $1,000, this X whatever to do this. I'm hoping I understand where we're headed. But we ask, what's your growth rate? What's your year-over-year change? You kind of hate going through this. What if you could buy exactly what you need? And what if every time you added that, you had linear performance out of it? So where are our jobs driven daily? You walk in the morning, what's the first thing you do? Check email. What's an email? Trouble tickets. Where trouble tickets come from? People. We love people, right? That's why we're in IT. We're huge people. It's the whole reason we have jobs today. So if we can set and meet expectations from people, if we can solve the people problem with technology, they're happier, we're happier, our significant others are happier when we go home. But it's all about meeting expectations. It's about this linear, predictable experience. Not just for VDI, for databases, for any type of app, for anything you're running inside your data center that works the way you expect it to every single time. So we've talked about this, right? Things come like this, we expect to build this, but let's change things a little bit. I didn't know whether I was doing this presentation before or after lunch, so you guys are not as hungry as you should have been during this session. But it's our favorite chocolate sandwich. We think it's actually pretty easy to make this. 2 slices of bread, peanut butter, jelly, and a knife. Makes sense? So I had to do this exercise as a kid in elementary school. The teacher said, write all the steps to make a peanut butter and jelly sandwich. I think this is really easy. So I thought I was a little nerd, and I talked about taking the lid off the peanut butter and spread it, and these things. I was like, hey, look at this, we'll do okay, right? Came back with a big red mark on it. She started writing things out beside it. Things like this. And she asked me, am I even in the kitchen? I don't know. Like, where else can you make a peanut butter jelly sandwich? Don't answer. The trouble is when we look at IT, well, you know, some of us have to Google. That happens. How do we do IT today? We don't know how it's happening. You go to Google. Right? It tells us how to make a peanut butter jelly sandwich. There were like 50 different results. I thought it was kind of funny. But what's the real goal of a peanut butter jelly sandwich? We're all technical minded, right? We're getting hung up on the instructions of making your peanut butter jelly sandwiches. They're perfectly aligned. You get the right PSI when you put those pieces of bread together, all kinds of stuff. And somebody's sitting there saying, just give me the sandwich. We forget about this as we go through this in IT every day. We think about the perfection of our infrastructure and how we're doing this and was it well documented. But really, there's somebody just waiting on a sandwich.
Yep.
So let's compare this to a task we do every day. Cloning a VM is not difficult, right? What do we do to clone a VM? Choose a VM, choose the host, choose the data store, we clone a VM. Pretty simple, isn't it? Okay, so let's be nerds. We're going to abstract this a little bit better. We've got to collect some CPU metrics. We've got to find the template we need. We're going to choose the least busy host in our cluster. We pick a data store based on capacity. We have to put it on some sort of network, right? Be a server, we serve something. We boot, patch the VM, and install the application. Pretty simple. Except there are some other pieces to it. Can we collect performance specs? Does that user know what they're trying to install? Did we find the right template? Was it sysprep? Was it an ISO? Was it stored in some folder? Can we choose the least busy host? Did you guys look before you started the wizard? No, we usually cancel the wizard, go back, find it again, go back and choose host number 3. Select the data store. We're going to talk about that in just a second because that gets kind of crazy. But did you ask for an key? Do we even know the network requirements? Is there a firewall thing involved? Microsoft, come on. And then we go to install the application. Who loves application management? Who's in charge of apps in here? I'm not offended by it. But it's always an application like, okay, who's managing this? Where's it installed? We do manage. Long story short, then we're even on the right SAN. Who knows? So let's talk about storage for a minute. Capacity, free space, thick, thin, future growth. Are we in gold, silver, bronze type? Is it on SATA? Is it on SAS? Do we have some flash in the environment? And then we get into snapshots, because that's usually how we define things today, by storage, right? It's by how we carve these things up. Is it 2 hours, 4 hours, weekly, daily? Do we have to put this in a specific tier? Is it a tier 1 app? Do we have to make sure it's replicated every so often? Most of that's handled at the storage level today. So we go back and we start reevaluating capacity and performance after we understand the snapshot and replication pieces. And then by the time we get to the end of it, right, we end up demotioning anyway because the whole petabyte requirements of microsecond latency the application known for didn't really need that. So we shifted somewhere more practical. But these are the steps we go through every single day. So what if it was as simple as just store a VM? We didn't have to think about the 17 steps it takes to make a peanut butter jelly sandwich every time we want to create a VM. What if it was as simple as a couple servers? We understand what a server is: CPU, RAM, memory, hard drive, some flash maybe. Disks in the front. What if we abstracted those disks? What if we ran everything from this little controller virtual machine, ran on top of each one of those servers? We created one storage pool. First, abstracting those disks from the server. Projector really is kind of dark. We create one data store. We present it to the hypervisors, and we run VMs. I'm auto-tiering, I'm balancing, I'm taking care of compression, deduplication, all these things for you. There's not all these thought processes we go into. It's literally create VM. Who's tried automation and orchestration? Kind of fun, right? UCS Director, Puppet Chef, all these things came out. We try to automate these things. The problem was is we had to go through those 17 steps. Was the computer good at making those choices? Kind of tough. So we're seeing automation and orchestration actually make its way back into enterprises, back in SMBs, because now we have a platform that can accept this. This is what Google and Amazon run. That's why it's so easy for you. Swipe a credit card, grab a VM, choose Windows, and it's up and running in 10 minutes. Because they don't have to think about all these pieces. We can bring that same stuff into your environment, into your infrastructure. Life gets a little better. We all work a little better. What if it's one-click management for all these things? Alerting, remediation. What if I lost a drive? And sure, I'll still replace it in 4 hours, but what if there was no RAID? What if I didn't worry about rebuilds and a hot spare kicking in and all kinds of stuff? What if it just simply redistributed itself across the cluster? And oh, by the way, most hyper-converged things start in 3s. So I already have one more storage controller than I had with a traditional SAN. Not to mention, as I scale, I go to 4, 5, 10, 20. So any performance impact I have becomes lessened. So I start caring less as I continue to scale. But one-click management, this ease of use becomes a big deal. Interfaces that aren't just single panes of glass, right? People throw bricks at those all the time. It's just information aggregators. I can put the same thing together in an Excel sheet. But what if I actually own that virtualization tier, and a storage tier, and a networking tier? Not just reporting on it, but I could actually operationalize that information. Because I own all those pieces, I make decisions in it. The software is actually smart enough to say, I see data all day long. You're an administrator. You look at me 10 times across the week. I see this every day, every second. So what if I made a better decision than you could? We see this automation of infrastructure starting to come into play. So if you talk about hybrid clouds and these enterprise clouds and all these technologies, it's always been hard to define. What does hybrid mean? Is that like battery, part gas, a car situation? We try to figure these things out. We hear terms all the time, and it's really difficult to actually put definitions to it. But we talk about needing something that's really simple to design and deploy. So if you can buy what you need today, we're taking the guesswork out of all these past collection tools and running things for 30 days to look at storage patterns and all this stuff. What if we actually just kind of knew you could buy today and get what you need tomorrow? You don't have to worry about these crazy procurement things. What if we install this in less than an hour? Not 2 days of PS, 5 days of PS, 20 days of PS. Most hyper-converged solutions, you show up about 9 o'clock, you rack and stack it, plug some cables in, you start to install, you go buy a nice lunch, you go back and run VMs. It's really that simple. When I add that next node, it's a 30-minute activity. Seamless. When I upgrade those systems, it happens unnoticed. Most people upgrade hyper-converged platforms. They barely know anything happened. They see a version number. They actually get kind of freaked out because they didn't see anything happen. That non-disruptive, that true architecture becomes kind of crazy. We talk about rapid linear scalability. This is time to market. This is risk reduction. This is meeting SLAs. This is being able to do the things that businesses need you to do quickly. Predictable performance. You don't want to have to deal with these stair-step methods every time I add a new tray of drives or every time I inject a new host or add something else. What if we actually understood those metrics and knew how this was going to scale? We want the state only to be available. This is the Google mantra. We want it up all the time. Why can't I? Somebody else can do it. Why can't you do it? And then we get into lower TCO. So we start trying to apply values to time and all kinds of stuff. I always look at it from the MasterCard perspective, right? What were the whole commercial schemes? It's priceless, right? It was always some event, some memory, something. What if I could say Memorial Day? You actually got to go play with your kids on the beach. What do half of us get stuck doing? SAN upgrades, network upgrades, software upgrades, something. Right? We get pulled away from our family all the time so that everybody else gets to hang out with their family just because we chose a certain profession. What if we could do upgrades during the day? What if they were non-disruptive? What if they worked as expected every time you click that button? This is what this world of hyper-convergence is bringing to us. So, the point of today, you can build your castle. You can own your castle. You can operate your castle. You can build it brick by brick. Different size bricks, whatever you need. And you can have peanut butter and jelly without all the crazy instructions, without all the pieces, without everything you have to put together. Man, you guys are asleep. I'm really sorry. Oh, it's super funny. No, but in all seriousness, this is what we're seeing as things transition. This is what hyper-convergence is doing. There's a lot of players in the market. You're seeing a lot of things come out. And part of it's this trust decision of how do I shift from what I've done today to what do I do next? Is this the next thing? Is this the fad? Is it going to disappear? Are we seeing this legitimately picked up by big organizations, or is this something that I added on? Is this for VDI only as a point solution? So maybe let's have a little conversation with you guys. What have you heard in the industry today? Are you seeing hyperconverge? Are you hearing about it? Do you know people that run it? You've got questions, concerns? What's top of mind for you guys?
So you talked about storage, resetting storage. In the past, I've seen most hyperconverged systems are all flash. So are they saying that screen?
Yeah, so there's usually a good mix. He's asking, are hyperconverged platforms going all flash, or most of them all flash? Where are we seeing things go? How are we adding capacity in these events? I would argue all flash is definitely on its way. You see a lot of storage vendors or RAIDs are coming in talking about sub-microsecond latency. We're seeing flash drives get to the point where they're affordable again. I mean, today, how much does a 6 terabyte SAN drive cost you? Maybe $200 off of new one, right? It's not terribly expensive. And so we've seen dedupe compression, some of those things kind of fall apart in that industry, but flash is still kind of pricey. And granted, we've seen the price come down. We're hearing all flash data center and those kind of things. But I would still argue there's a lot of room for hybrid arrays in the world. So as you talk about crazy workloads and all kinds of stuff, who here has a million IAP workload? Yeah. 50,000 IAP workload? 40, 20, 10, maybe. How many of you know what your workload is? But we want flash, right? It's fast. Why not? We solve developer problems, bad queries, all kinds of stuff with flash makes sense. But what if you could actually mix and match flash? So this is part of the thing that these arrays are doing, is taking the benefits of flash. Flash dedicated to every node in these scenarios. It's not only one big flash pool against your entire SAN where you have this victim and bully scenario. So I've got all my flash in the SAN today. I have one VM that chooses to write very heavily to that SAN. I can potentially disrupt operations for everything else in my environment. So what if I broke that flash up on a per server basis? So every server had 1.5 terabytes, 2 terabytes of flash. You can store hot data, do with things that move constantly. But the reality is less than 10 to 20% of the data on most servers today has any sort of transactional value. It's there, it's stale, it's last year's financials, it's backups, it's all kinds of stuff. So we still see a big piece of need for those big SATA drives in the environment. So it's finding that operational balance where you don't have to worry about tiering anymore. It's not that you pick the right storage tier, but what if it actually tiered it for you? And it did it real time, not on some schedule, not on the back end, but it actually understood those right patterns, could move that data seamlessly, unannounced to you or to the application. So I would argue flash is here, it's coming, we're gonna see a lot more of it. I don't think we're still saying maybe the top 10, 15% of workloads actually need all flash. It's really those big databases. Databases where all flash comes in two places. Sub-microsecond transactions. So I'm going to do a table scan. I need to look across my entire set of data, and every time I look at that, it needed to be returned in some small amount of time. Or we see it from an IOP. We understand that it's so unpredictable in those workloads that we just need to make sure it's solved. We never need to hit that top level performance threshold. We just want it to work every single time, and money's not an option. And that's usually where we see flash going to play. More people still sit in that hybrid type rate. How many people have flash in their data center today? So becoming more prevalent. If we asked you that 2 years ago, would you raise your hand? So we started seeing PAM cards and all kinds of stuff, different on-card memory. We saw SSDs come out. Now we're seeing MLC and TLC and all these new pieces come out. You're going to see capacity flash drives coming. Multitudes of terabytes, right? It's not going to be high transaction. It's still going to be faster than a spinning drive. But what you'll see a lot of these systems designed for is that we don't really care what that layer is called. Call it a hard drive or a SATA drive or SSD. It's this tier and that tier. So I can have fast and faster, fast and slow, whatever I want to mix. It's still tier between those. So these technologies are designed to keep up with the pace of innovation. Right? We talked about hardware that we don't care about. To us, it's just a storage tier. We just want it to work. I don't care what that is or what the brand name is on it or how many IOPS that individual thing delivers. I can still deal with it.
So one of the words that you are using a lot is hybrid. And for me, I think hybrid has to do with workload. Why don't I have a data center that is 80% right-sized and I have a transient load? I'm offloaded to swipe a card, VM, run it. But afterwards, I want it back. So how does the hybrid?
Yeah. No, you bring up a great point. So part of this is choosing what runs where, how do I move it, how do I transition it. And you're seeing a lot of the hyper converged players start to care less about the hypervisor itself or about what cloud they run on. So if you talk about hyper converged, we talk about needing CPU, RAM, some hard drive, and some performance tier. Sounds a lot like what Amazon sells, right? CPU, RAM, EC2, S3. So we start caring less about what those mediums are. Part of it now is about controlling the control planes and the data planes of these technologies. I want to move data back and forth. So I have some application, some social media application I start trying, some new IM program, Slack, whatever. So I don't know what my user count's going to be. I don't know how many people will log in. I don't know what the performance requirements are of this application, right? It's a document management system, whatever. So we tested with a couple of users. It's really easy in the cloud. It's a great place to start. And all of a sudden, next thing you know, you've got 10 terabytes worth of data up there scanned off your local copier. And it's like, how do I get that back? So part of what you're seeing is this integration in the cloud world of true hybrid cloud. So for us, it's always been kind of hard to define until we get to the point where we understand that there's this fabric in between. We have to have the data plane and the control plane between those two. So the control plane being the virtual plane. It's in a VM. I've got to have some power on functionality. I've got to have some network functionality, those kind of things. And the data plane meaning, do I have to replicate everything? Do I move back and forth? Can I do change block tracking, compression of wire? How do I move data to and from the cloud? Because you kind of get billed for that every time, right? Amazon loves to run that little ticker every time you move another, couple of gigs through their pipe. So we can do this efficiently. The whole idea is that within the next 6 months, you're going to see most of the companies starting to be able to move workloads to and from cloud. Because you get in things like nested hypervisors, like what Ravello's doing, Oracle recently purchased them. It's the ability to actually nest things on top of the hypervisors in cloud. You guys know what hypervisor Amazon runs today? No, my chief from this morning. It's Zen under the covers, but you don't know. You swipe your credit card, you expect it to work. So we're starting to care less about the virtualized layer 2. It's becoming commodity. And so the whole point being is that we're going to get to the point between OpenStack and all these different technologies that storage is storage, compute is compute, memory is memory. And we want to be able to shift this all around. It's the whole idea behind containers and Docker and stuff as well. We've got all these shared libraries, right? Back to basically old school Unix, where I'm partitioning all these things out. LPARs, all the things I did in the old school, is still coming back to today's technology, just in a virtualized world. But the whole idea is, yeah, that you're going to be able to seamlessly move an application from cloud to on-prem, from on-prem to cloud, without having to do data abstraction, rebuild VMs, and all kinds of stuff. Because we'll actually own those two planes, that fabric that makes that up, in the world of the virtualized piece and the data piece. It's all black box mind. It's magic, right? It just happens. Slides don't fail. How many of you guys play with Hyper Converged infrastructure? Seen demos? Do anything? Does it seem too good to be true? I like honest feedback.
I think we're back to where we were in early 2000s. We used to have a single server, and some memory, and some CPUs, start an application, and then a second application. Then it got too busy. So we're back to the beginning. Now we're back to the single server, back to storage.
So you're saying history repeats itself.
Yep.
We've seen this over and over again. It really is. I mean, the world hasn't changed that much, but we've seen software outpace hardware, and that's really what we catch up to. So I looked at it a couple years ago and said, Intel's coming out with another processor. Wow. Like, mine's not busy today. Like, I can't max out the processor on my PC. But we're starting to see density increase and things happen in different technologies like this, where storage now takes part of CPU. How many of your virtual environments are CPU bound?
Makes sense because the minute it isn't.
Very few, right? You might have one report or two, something that handles a SQL server every now and then. For the most part, you're still sitting there, even with virtualization, you're less than 50 to 60% utilized. So as we look at ways to make that more effective and to bring software on these really fast Intel chips, not worrying about drive apps and all kinds of stuff, but if we can get speed from software and innovation from software, that's what smartphones did for us. We don't have to go through these old CDMA technologies and all this kind of stuff. Now there's LTE4, sure, there's still a chip and a radio. But every new feature, every new app I have, I gain functionality by simply downloading and clicking a button. So what if the data center in 6 months to a year looked like SQL servers and app? Today we go through this wizard. Buy licensing, set it all up. We talk about instances and users and tempDB and logs and data stores and all kinds of stuff. What if that was done? What if it was like SQL instance, SAP, Office, Excel. We're already seeing these delivered as apps today, right? It's what Office 365 does. We've seen this shift under our nose. We don't really pay attention. We're kind of happy about it. But what if that's the way the world's going? What if some of these manual transaction play with all this kind of stuff disappears? So we've seen this in semi-trucks today. You guys seen the new semi-trucks? Kind of cool. All automated, right? Used to shifting through all 18 gears, all kinds of stuff. Today they're on GPS track. They're looking at, tenths of fuel in gallons of miles per second. And they're looking at elevation and grades and downshifting automatically, knowing they're coming up on a 2% grade, and they're trying to save fuel over the next 100 yards as they get to the top of that hill. Like, this is where we've seen the world come through with all this data, with all these analytics. So as we see our consumerized lives change, I really think we'll see those data center lives change too. Where apps are really more like an app store, not like an installable that you get on ISO. We're going to see that data center mold into something that really is kind of put together in a brick-by-brick basis. We're still going to have networking complexities and different stuff. But we're seeing SDN come in a big way too. You guys playing with SDN today? Simple switches, programmable. What if I could actually plug a device up and buy MAC address? It realizes what that device is, automatically configure my VLANs, my ACLs, and talk to my firewall to give the security policies I need. It's all identity management. If I log into a VDI session today, my apps are delivered by what I have permission to. By the way, the resources I got allocated to that too. This is what we're seeing. And what it is we're looking at moving into a platform that can adjust like that. Legacy technology has a hard time. How do I scale inside an environment that was built for virtualization on top of old architecture? I need something new, right? And Einstein kind of said it. I have to start thinking about things differently than I used to solve those problems that are coming in front of me. Apparently you did a better job. I do appreciate your time. Like I say, we're happy to chat. Again, we'll talk a little bit. We can chat in the future, what we see in technology, what's happening about specific products, whatever makes sense for you all. So I really appreciate the time today. I know the after lunch session is always full belly and catching up on emails. So I really appreciate the time.
All right. Thank you.